2-hour session, and we're going to hear from 4 or 5 presentations that run for 20 to 30 minutes. So brace yourselves. We're going to be dealing with some new technologies, and we're going to be looking in depth at some of those technologies that we present today. I'm Roger Gilbert. I'm the publisher of the International Aquafeed magazine, International Pet Food magazine, but more importantly, Milling and Grain. And on some of the chairs you will find these 2 cards. This one gives you access to our magazines, the latest edition, whenever you use that QR code. And on the back, if you want to read us in another language, there's 6 other languages you can choose from. So please take one of those if you can find one. And this orange one is also our directory. It's an annual directory that's online, but you can also read it as a directory on that QR code. So, that's me. By the way, Milling and Grain magazine has been published for over 130 years. It was first published in 1891. It's the longest standing magazine in print, still in print in our industry worldwide. We're very proud of it, and I think you as an industry are very proud of it as well, because we know we have fabulous readers all over the globe. My first duty is to say that we are only here because of Victam and Victam Asia. Victam International, the organisers out of Holland, have kindly partnered with us, or invited us to be their partner, in hosting these very short, focused events that look at the technology we are using or planning to use in the food industry. And I'm very pleased to say that I have Sebastian here with me. He's the General Manager of Victam International, and he'd like to say a few words of welcome as well. Sebastian.
Thank you, Roger. First of all, there's some seats left here, so people standing here, 2 more rows. No, very welcome. Thank you very much, Roger. It's not the first time that I'm here, that you are here, and that we're together here. We do those Maximised now for, I think, for 3-4 editions, and every time it's a bigger success. More technology coming up, and so I'm very happy that everyone is here again today. Not only here, but also at the Victam event downstairs for the next 2 days. So hopefully everybody enjoys. Hopefully you make a lot of good contacts, and maybe even a small cocktail at 6 o'clock at the exhibition. So I wish everyone a good session here.
Thank you, Sebastian. Did you say cocktails at 6 o'clock? Just want to remind everybody. Okay, so later on, if you have a chance, please join us. Without further delay, I'd like to move straight into our first presenter, who is Dana Nelson from Famsun. He's going to talk to us about practical considerations for producing premium quality sinking and floating aquafeed. Now, Dana and I, we know each other some time, and he has an extensive 40 years as a veteran in aquaculture and in aquafeed manufacturing. He's from Salt Lake City in Utah. He owned Nelson and Sons and Silver Cup Feeds, well known for producing high quality, innovative aquafeeds itself. After selling the business over a decade ago, Dana began a new career working with companies offering extrusion equipment. Dana now serves the aquaculture as aquafeed technical director for Famsun in the USA. Dana, please, the floor is yours.
Thanks for the introduction. I have known Roger for a little while. This isn't the first conference that I've presented at, but it is one of the few that I've presented at that's more general in terms of the information that I'll be talking about today. Roger already gave me a flattering introduction. I don't have a formal education in the subject and the topics that I'll be talking about today. It's mostly just been my involvement with the family feed business. My grandfather was in the general feed business many, many years ago, and that business slowly evolved into a hyper-specialized company making just aquatic feeds. So after selling that business to Scredding, which is a global company that some of you may be familiar with, I worked on their transition team for 3 years, and then I just recently left the Wenger Group. Extratech is an extrusion equipment supplier, and I'm new to the Famsun Group. I have a few colleagues here. For those of you who I do know through other connections, it's good to see you. For those of you who don't know me, feel free to approach me after if you have any questions. It'll be interesting to see how this discussion goes. So, I've heard a lot of different definitions for cooking extrusion or extrusion over the years. I tried to, with my topic being practical discussions, I tried to approach it more of a layman's terms. So this definition may be a little bit longer. I've used the standard definitions that have been used in the past. I'm hoping this definition will be more practical, easier to understand for people who are new to extrusion. So the first component would be extrusion is simply the process of forcing the material through an opening in a die to make a shape. Cooking extrusion, in particular, the technology that's used to make animal feeds, pet foods, a lot of food products, and the area where I'm the most specialized in aquatic feed, uses energy inputs that are both from thermal sources and mechanical. So there's two primary different sources of heat that are used in the process. Thermal inputs come from the direct use of steam. So raw steam is introduced into the process directly. That would be considered thermal energy. The mechanical comes from the extruder screw, die configuration, and the friction that results from these components. It sounds kind of non-intuitive, but single screw extruders in particular, and even twin screws to some extent, are designed to be inefficient. They impart force onto the product in the forming process that is inefficient, and the resulting inefficiency equates to friction and heat. And then that gives the process the ability to have very high temperatures if those are desired. During the process, and this is the key variable that I think sometimes is missed when extrusion is introduced, is that some percentage, it depends on the formulation, some percentage of the raw materials that are in the dry mix actually transition from solids into either a gel or a liquid, so they melt. That's the best terminology I can think of to use. And then when they exit the process, they come out through the die, they transition almost instantaneously back into a solid again. So that's my general kind of definition of extrusion. I don't want to spend a lot of time going into the technical details, but I did want to introduce these main steps before I show a short animation video that shows kind of the raw materials being transported through the system. The live bin is probably the first component that's considered part of the extrusion process, and it's really the raw material storage area. And the primary purpose of the live bin and the feeder are to have very precise control over the inputs of the dry raw materials into the system. The third step is, in this particular conditioning system that's illustrated here is a triple conditioner. That's the type. But there's lots of different conditioning systems that are dependent on the products being produced, and different manufacturers have different approaches to different conditioning systems. But in either case, this is where the liquids and the dry steam is introduced into the process. The conditioning is the first step. After the raw materials are wetted with liquids, lipids, sometimes other liquid additives, they're transported then into the extruder, and the extruder is basically just a very heavy-duty flighted conveying system, a screw conveyor, that becomes inefficient because of the placement of the die. And the die is the final kind of spot. In this case, there's an assembly or a hood that covers that for safety purposes and for containment purposes. When the product exits through the die, and you'll see this in the illustration coming, then the product is cut into uniform sizes and shapes. The other piece of ancillary equipment that's really integral or critical to the extrusion process is the method that you're introducing the other ingredients, the liquid ingredients. And in this case, water, steam, oil. Sometimes there's fresh meat, slurries, and other liquid ingredients that are introduced also. Here's just an animation of what I just kind of roughly just described. You can see the raw materials entering into the feed screw. Again, this is a very controlled method for controlling a very exact amount of dry raw materials that are introduced into this conditioning system. This point, liquids are introduced and mixed very aggressively into the process. After they've been wetted, those raw materials drop into the extrusion system, and then this animation is intended to show that the raw materials are transitioning from individual raw materials into a dough-like material. And then as they exit the die, this is an illustration showing how the die cuts the product as it exits the system. And that in and of itself is basically the introduction to extrusion. Prior to extrusion becoming a popular method for forming product, by far, and still even globally, the more common way of producing animal feeds and even aquatic feeds is a steam pelleting process. Steam pelleting process has been used for a much longer period of time than the cooking extrusion process. But there's a slow transition with aquaculture where more and more and more of those feeds are being extruded now than they are steam pelleted. And the reasons for that is because there are some advantages to extrusion. The heat process actually improves the nutritional value of most raw materials when they're in a raw state, especially as it applies to some particular aquatic species. And I won't go into the strong, in-depth discussion about this, but I did want to just make it known that the extrusion process, the cooking process, actually improves the bioavailability or the nutritional availability of certain raw materials. The ability to form pellets with a desired bulk density. I kind of went backwards there. Obviously, with aquaculture species, there's a value in being able to control whether the product floats, or whether it sinks, or whether it sinks slowly, how its behavior is in water. And then the physical characteristics, what the texture is also critical, depending on what species is being fed. And extruders have the ability to control that. For those of you who are completely new to extrusion technology, breakfast cereals, snack foods, a lot of human food products are manufactured on very similar equipment. And again, those products tend to be expanded and have a different feel. The other product that's manufactured in the same way is dry dog and cat foods. So the other advantage of cooking extrusion is that it permits the addition of a larger amount of oil and fat to be carried on the pellet than what you could ever accomplish with pelleting equipment. The limitation for fat contents in pelleted feeds is quite low. Introduction of more fat makes those more friable, they're less durable. And so if there's high fat contents that are achieved, the best example would be salmon feeds. People don't know this, but a lot of salmon feed producers are capable of pushing the fat contents up as high as 40 to 45% when it's necessary. So very high levels of lipids, and extrusion allows that to happen. The pellet characteristics are also superior. They're much more durable pellets. They're less vulnerable to breakage in storage and handling and in feed systems and transport systems. They also, because of the thermal transition, that glass transition that we talked about, that melting step, they're much more durable in water over time. So any species that takes a great deal of time to find the feed or to consume the feed, it's important that feed doesn't break down in the water over time, and that's something that extrusion has the ability to do also. I mentioned the improved feed performance because of the raw materials. There's also improved feed performance because there's less waste. And there's less impact or leaching into the environment because the feeds are more stable. So what are some of the disadvantages? Shrimp feeds, for example, even though extrusion technology has been available for over 40 years, a majority of the shrimp feeds that are being used globally are still steam pelleted. And so why would that be? Well, there's a higher capital investment to put in extrusion equipment, much higher than a pellet mill. There's higher operational costs. Those operational costs are due to the additional energy that's required that we just described earlier in melting the product. And probably the biggest factor is that because elevated moisture contents are used during extrusion, to make those products stable and not require refrigeration or special storage, you need to remove the water, remove the moisture content. Probably be talking about that, some of the storage considerations. Moisture needs to be removed, and the drying step can be very costly. With steam pelleting, a drying step is generally not required. And then finally, it's a much more complex process. So you need more sophisticated controls, more sophisticated operators. It's quite common now for extrusion systems to be highly automated. If you see walking the floor with some of the extrusion equipment companies, you'll see a lot of attention to new automation systems to make these systems less dependent on the art of an extruder operator or the experience of an extruder operator. So, but again, those extruder operators requires greater control over the inputs and greater operational skill. So I've already touched on these a little bit, but I wanted to re-emphasize again that the most important physical quality specifications associated with aquafeeds are first the ability to control the density. The second one is the pellet durability. That's another major category. I'm being redundant now. And then the third one is that water stability that we already talked about. Those are probably the key. There's other subcategories and maybe even separate categories, but these are the primary categories that I wanted to discuss today. So I started this slide with the guy with his head in the sand. I don't know if it's appropriate. Certainly don't want to suggest that there's anything naive or stupid going on there, but I wanted to point out that the greatest strength and weakness of extrusion is related to the same thing. And this is kind of an advanced extrusion concept, but one that I think is overlooked. And I'm hopefully that those of you who are here that know about extrusion will find this interesting. Cooking extruders' use of heat and moisture is fundamental to their superior ability to form raw materials into these premium shapes of exact density and durability. So it's correlated to that heat and moisture. Heat and moisture processing directly correlate with the quality due to this class transition, that melting process that we talked about. And the main raw materials that melt, just as a sideline information, is usually the carbohydrate. The starch is the fraction of the formulation that melts. There are some proteins that transition also during that melting process, but it's primarily from the carbohydrates. Again, the durable pellets, the fine cell structure that we talked about to carry high fat contents, all of these, the water stability, all the things that I've already talked about are all dependent on heat and moisture. So those improved feed conversion ratios and growth rates that the species benefits from, again, directly correlated to heat and moisture. And this is the main punchline. Unfortunately, the typical extrusion parameters that influence these characteristics, all these benefits, also promote expansion. So when you think about breakfast cereal or snack food, a Cheeto or a Cocoa Puff or a Cheerio, those are all light, expanded products. So if you're after a floating product, that's not a problem. But if you're after a very dense, heavy product, extruders don't like to make a heavy, dense product because of the heat and moisture that's associated that causes that. We'll go into some specific details with that. So this illustration is just kind of representative of the process. It's not an accurate illustration by any means. The box on the left is supposed to represent the extruder barrel, the screw and the barrel. There's several openings in the die plate. This is just showing one individual opening. That would be rare to be extruded through one. But the point is for you to see an illustration of how the product expands as it comes out and why it expands. There's a lot of misunderstanding about why product expands, and the immediate assumption is that it's related to the pressure, and that somehow when the pressure changes, and I want to go into some details on that to be more exact. So inside the barrel, you can be at quite high pressures. 20 bar would not be an unusual pressure at all for extrusion. That's as high as, for those of you from the US or from the UK, 300 psi would be the equivalent. Water at those pressures has a boiling point of 214 degrees Celsius, much higher than the normal boiling point. So it's important to understand this because the water is still in a water state when it's inside the extruder. But when the product exits, any moisture that's in that product almost immediately flash evaporates. And that flash evaporation is like a little explosion. And the other raw materials that were in a gel type or a dough-like state have become elastic and they expand. If there isn't enough raw materials that are in that glass transition state, there's literally just an explosion and it just texturizes, just blows the raw materials all apart. But if there's enough elasticity to it to hold it all together, it usually expands, and that's where that expansion comes from. So we've already kind of hit on this in an effort to kind of keep the discussion moving. The unfortunate part is it's related to some products that need to be dense. So if you want a product that isn't expanded, then oftentimes the solution is to hold back the moisture content and the heat in the process. So I don't know if there's any of you who are here that operate extrusion equipment, but when you move to make a denser product, the first thing that happens is you're usually looking to remove moisture and remove heat from the process. But unfortunately, when you do that, all of those quality characteristics that I mentioned earlier start to degrade. So you lose all of those values, and that's the unfortunate part of the message. So producing floating feeds is generally much easier than making sinking feeds, and these are just some illustrations. That's some pet foods at the top. These are different illustrations. That's an aquatic feed. Most products that are extruded are expanded and would float. Almost all extruded products. Pet food has densities that it would float if you threw it in water. Snack foods, breakfast cereals, they're all expanded. Salmon feed, for those of you who know about salmon feed, that's a sinking feed. But off the end of the extruder, it wouldn't normally sink. It only sinks because the pores of that feed are filled with oil, and then it has a sinking characteristics. So these are the different bulk densities. I didn't want to get into too much detail here, but I just wanted to let you know that these concepts are very well understood by people who manage, sell, and operate extrusion equipment, because controlling the density is one of the primary, again, advantages of cooking extrusion, is so that you can control the density of the feed. And these are just some general numbers of different types of densities that you would see for neutral feeds, slow sinking feeds, fast sinking feeds. And then the relationship between moisture content in there. And it's actually a curve. Again, I think I'll skip over this. I don't want to go into a bunch of detail, but as you might imagine, when moisture is elevated in the extrusion process, it actually lubricates the process, and so the heat actually is reduced because the moisture content then begins to act like a lubrication to the process. So there's actually a curve where low moisture means more expansion and high moisture means more expansion. So, but when it comes to sinking feeds, they need to be able to sink in a predictable way. They need to have all of those same quality characteristics that we discussed. And this would be particularly the case with shrimp feeds. It needs to be 100% sinking, and then it needs to be cooked sufficiently enough that it's stable in water for very long periods of time. If it's not, then the nutrient, all the expensive raw materials aren't successfully introduced to the shrimp, and it obviously leaches into the environment and has unintended consequences in using it that way. So controlling expansion is not a new problem. Extruder manufacturers have known about it for a long period of time, and they've come up with different methods to help deal with that expansion. And the first one occurred probably 40 to 50 years ago in some of the first extruders, where the screw elements that are used in the extrusion process are segmented. They can be removed and changed. So you can actually change the way the extruder is configured to control how much mechanical energy is imparted into the process. And those can go from a very aggressive configuration. This number 1 illustration shows a screw profile that's intended really mostly to convey, not necessarily gently, but mostly it's a motive to convey. Whereas the one on the 6th, there's some interruptions to the flight. There's larger steam locks that are used to actually purposely make it less efficient. The other method people have used, the extrusion industry has used to help control expansion, is they'll put a vent on the barrel. So they'll actually let water and vapor escape from the extrusion process and heat escape from the process before the forming step. And then that reduces the amount of expansion that occurs from the die, because a lot of that moisture and energy is allowed to escape from the extruded barrel, and then the final part of the machine is just used for forming. The vacuum can be applied to that, but again, the key is that it reduces pressure, reduces moisture. Flash evaporation cools the product very rapidly, so it reduces the temperature through evaporative cooling. And back to that illustration that I showed before, that expansion thing. The next innovation that occurs that's now very popular, several extrusion manufacturers are offering this. They'll place the extrusion die under pressure. So now you have less expansion occurring at the die because it's no longer at an ambient pressure. So the die, as the product actually exits the extrusion process while it's still under pressure, typically between maybe 1 or 2 bar. And so the expansion is less violent because the boiling point of the water is higher because the die is under pressure. So that's another common method that's very popular now for producing aquatic feeds. So these pressurized die chambers, the pellets exit the die, but again, they enter into a pressurized environment that elevates the boiling point or the vapor pressure force of the water that makes the expansion less violent. So that's already now I've covered. I think we're probably almost out of time, Roger. I didn't even notice what time it was when I started. I'm going to go through just quickly and just mention the other key variables. Like a lot of other manufacturing processes, there's other steps in the process that are critical. I've talked a lot about extrusion, but mixing the raw materials is absolutely critical. You have to have good mixing in the extrusion process to have success. Each kibble needs to contain the same proportion of ingredients, and you have to have good homogeneity. These are all, again, practical steps that are critical to the process. The next step, I'm going to just blow through these slides quickly just to discuss. There's not all mixers that are used in feed manufacturing are the same. There's lots of different mixing technologies, and these need to be considered when you're choosing what extrusion goals are needed. You need to select the right mixing process. But again, high CVs are achieved by time usually. There's more intensive mixing systems that can achieve very homogeneous mixes quicker. Other mixing technologies take more time. Grinding could be a whole separate workshop.
I have one question.
Okay.
What would be the ideal CV that you would recommend?
I don't know that there is an ideal CV. Typical CVs for extrusion process is between 3 and 6.
3 and 6.
Yeah, I don't know if there is a better, the lower the CV is, the better the mix. And the better the mix, the more stable the extrusion process is going to be. And then obviously your homogeneity and your nutrient profile per pellet is going to be better. So, Roger, we are almost out of time. I think I'm going to go ahead and shut it down. There are several steps that we could go over. For those of you who are in the audience that have additional questions, feel free to approach me. I'm here at the show all week in the Famsun group. If you have any questions, please let me know.
Dana.
Thank you.
Thank you very much. Very good.
Who's next?
Okay. As you can imagine, some of these topics can go into quite some detail, and that's what we're here for. So, Dana, thank you very much
Thanks,
for
Roger.
an inside look at extrusion processing, right from the ground upwards. Okay, so our second speaker today is from ANDRITZ. It's P Angamuthu. He's going to speak to us today on build or expand quickly your animal feed production with its modular plant solution. KP has three decades of industrial experience, and I think this is very important to us. We as an industry need to think outside the box. There are people outside our industry who come into our industry with really good ideas. And if you listen to this CV, I think we're benefiting from some of this value. 3 decades of industrial experience across diverse sectors, including paper, textile, poultry, animal vaccines, feed projects, and manufacturing, power plants, food processing, and soy and edible oil refineries. I mean, that's a fantastic CV for us to have within our industry. 10 years focused exclusively on feed equipment and plant sales. Progressed from field roles to top management, serves as GM, projects and executive director for a €1 billion company. Welcome, KP.
Thank you, sir. Thank you very much. And I'm KP from ANDRITZ. I'm taking care of the business in Asia Pacific. I'm regional director for Asia Pacific, operating from India, taking care of all these Asia Pacific countries. Now we are coming up with we are very dominant in the plant solution activities. That means we want to deliver the turnkey projects. Now we are coming up with a solution for the customers, and which they want to open up a new market wherever they want, and they don't want to go for a permanent infrastructure or something. So we are coming up with a modular plant solutions. So if some customers wants to start a business in one of the new area, which they don't want to go for a big investment, they can hire a warehouse and they can install these modular plants. So they can, after some time, once they establish a sufficient volume of the feed, then they can move these modular plants in some new locations. That is how it is. So the standard prototype, we come up with a 10 tons per hour animal feed plant, which you can utilize for the poultry feed, swine feed, as well as for the dairy feed. And this is the typical picture. You can see how this modular plant is demonstrated. You can see this exact model we kept in our booth, in ANDRITZ booth in hall number 102. And this is a type of the poultry feed with the 10 tons per hour. And this solution we are trying to push for the Middle East Africa as well as Asia Pacific at the moment. And this is suitable for the raw materials. You can take it from the warehouse in bags and small bulk, because we have this design is post grinding design, and you can produce in this modular plant pellets, crumbles and mash as well. You can size, you can take it to 3.5 to even 6 mm level. For the dairy feed you can go up to 8 mm as well. The outloading is currently we are giving up with a normal bagging. And how this the installation looks like. All modules are pre-assembled at our factory in China and at our ANDRITZ workshop, and we completely assembled tested and then disassembled the same thing. So this ease of logistic operations and easy erection on site. We have installed a model plant in India at near Delhi for a company called Kahl, and that plant, the maximum capacity of the plant is 5,000 tons and consistently last 6 months producing around 4,700 4,800 tons, and they installed this in a open platform warehouse, and after that they covered with the sheds. So the usage time for the installation is hardly 2 months. So the manufacturing of these complete modulars is taking 4 months and installation time 2 months. And the benefits of this modular plant is, say example, there is no effortless planning. So suddenly if some market comes, they want to capture this market in any one new country in a small areas, immediately they can call for us and we will solve your problem. And there is no complicated constructions and commissioning involved, because very short time you can do it, and then there is a total peace of mind for the customer because it is a fit and run. And then local support we have in Asia Pacific and Middle East Africa, wherever which country we have local support. We have a team of the turnkey expertise peoples are there. So these solutions comes from a global expertise with the local solutions. So there is a smart engineering and the project expertise we have, because this concept created by, I have around 30 plus years experience on the project management and site management and the project execution. So the maximize our end-to-end value chain to the customer. That's how we are coming up with these modular solutions. And the technical features of this is the total overall height of a 10 tons per hour plant is 16 meters, fits in the existing warehouse. Normally a 10 tons per hour turnkey plant will have a mill tower of at least 29 meters. So the 29 meters we reduced into a 16 meter height. So any hired warehouse we can push this into that. Then no building is required. The complete steel structure comes with solution. No need of you need to give a complete the platforms. We will keep our the containerized the modular solution into the warehouse. Everything is included. What are all included in this? The equipments of the key equipments like hammer mill, mixer, crumblers, sieve, pellet mills, conditioners, everything is included, plus all the transport equipments like conveyors, elevators, all also included the complete electrification. You need to give a plug of one incoming to our MCCs. From the MCCs we take our cables and automation. Everything cable trays are prefixed, so then we will just connect the cables in a fastest manner. Then also included the buildings, platforms, but any elevator heads you need to approach, then those platforms are included. Staircase you can see on there are 2 places, and handrails also. So we also comes with our 2 supervisors to oversee the installation installed with the local cranes, and 3 engineers. Local jobs, what you need to do here. The wiring of powers and controls which we will do at the site, and the piping for the compressed air, because plug and play, because wherever you want to connect you can connect it. Then the piping of the steam lines. So you should have a separate boiler, separate air compressor. These pipelines if we connect, then you will run the plant. Then of course at the end of the day commissioning is included, which we ANDRITZ will try to help you. And this what is included in the flow diagram, you can say intake, cleaning, dosing. There are 8 batching bins are included in this, and the grinding, since it is a post grinding application, then after that grinding is a mixer. Our Optimised is included in this. Then the feeder, and then conditioning, then pellet mill, then of course there is a counterflow cooler and the crumbler, then finally the pellet screens. Then we will go with the bags. Bags you can start bagging with 10 kg to 80 kg, depends on your requirement. And this is a typical flow diagram which is included inside the modular sections, and you can see the one intake with an elevators and the cleaning and the magnet, and then go with another elevator. Then we have 8 batching bins, and from there we have 2 dosing scales, and you can parallelly dose it, because this will ease out increase your productivity. Instead of only 1 wave hopper, we kept 2 wave hoppers, and there is the batch conveyors, batch elevator, then it goes to a hammer mill. There are 2 bins, bin above hammer mill, and then it goes to a mixer, and mixer we have an Optimix, the fastest mixing solution which is launched in 3-4 years before, and then the manually premix you can dose it, then again it will go to the mix feed elevator, then you can see the feeder, and then we are coming up with the 2 conditioners. So each conditioner will give 60 seconds retention time. So 2 conditioners you can get around 2 minutes of retention time from these conditioners. Then the pellet mill, of course, it is a gear driven pellet mill, which is our long time success pellet mills in Asia Pacific and Middle East Africa. And also we go with a counterflow cooler, then the screen, and then bagging. So this is a typical flow diagram which all the participants knows, but this squeezed into this modular plant, that is our success story. And you can see the dimensions. The site, the width of the modular is 35 meter and length is 17 meter. So we need a size is 35 by 17, and site area is very minimum, that is 600 square meter is enough to install this. And normally a 10 tons per hour plant needs, in a vertical also you need at least 1800 square meter. But in this case we come up with a very limited requirement of around 600 square meter, and maximum height is 16 meter. We limited the height because some of the customers wants to install in the existing warehouse, and then the pit depth is going down is 3.5 meter. And you can see where we placed. The one is intake pit, which need to be created by customer at the location because we need to dump. And the second one is cleaning sections, the third one is the dosing sections with the batching bins, and the fourth one is the grinding section. Hammer mills are placed. The 5th modular we have a mixing section, the mixers are placed. The 6th one is pelleting section, pellet mill, conditioners and coolers, that vertical is placed. And then the 7th one is bagging. Then 8th place we kept our MCC and operating cabinet. This, you can see the isometric view how this is installed. Actually personally I experienced this. We manufactured this with 4 months and ship it from China. The shipping time is almost 3 weeks from China to Mumbai, and from there the installation comes with 2 months and commissioning takes 1 week. So then we are ready to run the plant. You can see another view of the this one, how the modulars are placed and how the ground floor we can see all the elevator boots are there, elevator heads are there, and the batching bins you can see, all the bagging bins you can see. This is what typically it looks like. And this is another side view. You can see on the modulars how this is placed in the third view. All the machines are pre-installed, no need of installing at site. The modulars we will take it through crane and keep it with equipments. So you can see a typical this one modular is with pellet mill, we lifted and installed like that. The frame module dimensions are, there are 29 modulars are coming. Each modular you can see is a container, and each is 5.7 meter by 2.5 meter by 2.25 meter, including 2 MCC modules. And the frames constitute the building. Finally you can get the bolt nuts at the site. And effective usage of expensive crane time on site, because any project installation need lot of time, lot of crane times. So we want to reduce that. So that's why the frames are pre-assembled and dismantled in our factory. And the frames are hoisted from open top containers. All the modulars are open top. You can install wherever it is required and stacked one after other. And then elevator support structures also comes separately, but that we can install. So everything is included, that right side, cable trays, pipes, and the floors, stairs, rails, catwalks, flanges and transitions, bolt nuts also included in the scope. What is the typical formula? Of course, this we can say change the customer to customer. Right now, this poultry formula we have shown, corn is 50%, soybean meal 20, oil cake is 20. Then I think everybody, all the customer knows what is the formula inclusion here. There is a hand addition for the some of the items you want to add in manually. Half cubic meter intake for bags and small trucks is an intake. The pipe magnet removes the iron particles, and then the rotary pre-cleaner, drum cleaner is included to remove the foreign matters, and then dust aspiration filter and fan is there to suppress the dust. Dosing and weighing, 8 pieces of 10 cubic meter batching bins are included for the raw materials. There are 8 types of material, or otherwise you can go with 6 types of materials. You can utilize the multiple bins. There are 2 weigh hoppers, and then there is a screw feeders, and then batching conveyor to hammer mill. That is in the batching side. And in the grinding section, you have a 2 pre-bins, each 2 cubic meter. So that means 1 ton batch we are talking about. So 1 ton batch, we can go up to 10-11 batches in our mixer. So 10 to 11 tons you can produce in this modular. And there are rotary pocket feeders, removes iron and stones, and we have a separator included in our hammer mill. Then filters are there. The fan of size 6500 cubic meter is included. Then the hammer mill what we proposed is our unique hammer mill Optimill 500, which normally we used to give for a 10 tons per hour plant. And then you can go for a screen, say as much as you want, 3.54 or 6, whatever depends on your formula. Then there is a hammer mill below, collecting bin, discharge crow, then exhaust with silencer also included to cooperate with the pollution norms within the noise level. Mixing section, there is a pre-bin above the mixer, that is a 2 cubic meter, again 1 ton batch, and hand addition is included. Then oil from weighing tank is included in that. The single shaft paddle mixer of 1 ton batch. This is what I explained, and we can achieve with this the CV of 4.2 we can achieve with this Optimix, and the cycle time is maximum 300 to 360 seconds. That's what we come up with. Pelleting, 2 500 liter conditioners with I think we installed the conditioners with a bigger one to suitable for 60 seconds of 1000 liters, and that also included. Then pelleting is included. The model of pellet mills is a gear driven pellet mill PM615XW. It is a champion pellet mill in Asia Pacific with a 160 kilowatt motor. Then counterflow cooler of model SCCS 15 model, which is suitable for a 15 tons per hour, but we here for the critical applications like Bangladesh and other places, we are coming up with a 10 tons per hour requirement. Crumblers of course included with 22 kilowatt crumbler. And the screening and bagging in the last section, you can see there is a dual deck screening is there, and model TXQL 150 by 200. Then finished goods bins, 2 bins we are coming up with a 10 cubic meter. So you can store at least 5 to 6 tons in each bins. So 2 hours storage you can store. Then the bagging, 250 to 300 bags per hour. Of course, it is a normal bagging machine with an automatic sewing and belt conveyor and dust filters. So liquid tanks we are giving with 1000 liter with agitator for a day tank plus a pump. What are all the utilities which is depends on the customer? Steam boiler, compressed air generator is needed, and this is all optional. If the customer wants us to supply, this also we will supply as a package. Installation process, how it is going to be: the project execution and planning, site operation, site preparation, the frame hoisting, the frame assembly at the site, mechanical transition connections, electrical cable connections, and commissioning. This is what the execution. And I already explained the key equipment summary, and the power for this, the hammer mill requires 132 kilowatt and mixer 18 kilowatt, and the conditioner 2 into 15 or 18 kilowatt, pellet mill is 160, then cooler is 37 kilowatt, crumbler 22 kilowatt. This is the total power requirement for the key equipments. And each hammer mill specifications, you can see it is a horizontal aspirated hammer mill. This can go up with the 10 to 15 tons per hour, 132 kilowatt, and this is how we are supplied a lot of hammer mills in our Asian market. Mixer, it is single shaft paddle mixer, 10 to 11 batches you can take, of course they mentioned 12 but 11 batches you can mention, then the pre-bin and surge bin is included. And the conditioners I explained, you can go with 500 liters or 1000 liters, depends on the customer requirement. Pellet mill, of course this is our champion pellet mill PM615XW, a lot we supplied in this market, and the same thing we incorporated into this one. Then finally cooler, counterflow cooler, this is also very popular in the market, and this is the total power supply. Total power supply is around this one. What is the expectations like? And the steam for conditioner, it is a 1 ton boiler is required from a customer side, and then this all PRS station is included in our scope. Erection need around they initially fixed with 90 days, but we could able to complete within 60 days to urgent requirement for a Kargil. That's how we come up with 2 months we can install. And this is the total requirement, how we are going to do that, project management, how many days, and total these you can see the counting days from the start to end. When a customer decided to go with a modular plant, from start to end these many days are required to produce a 5000 ton requirement of poultry feed or dairy feed requirement. This is how within 20 minutes I can give you a presentation. Hope you enjoyed this, and if you have any doubts on this modular plant requirement on the plant solution side, you can reach us in hall number 102. Thank you very much.
Thank you. Thank you. Thank you, KP. There's just one question I have. How much is it going to cost? But that's not really the point. I think what the point is that it's modular, it can be built in 90 days or so, and you're in production. You can concentrate on the business of producing the right feed. And I think it's a fantastic way to get into feed milling if you're in a new area, new region, or developing for the first time. Yeah, congratulations on that. Thank you very much.
Thank you.
Okay, our third presenter is Neal. He's from Hydronix, and he's going to talk to us about that very important subject of moisture. Why moisture control matters in feed milling. And we all know it really does matter, but first let me tell you a little bit about Neal. After gaining his degree in electronic engineering from the University of Southampton in England, he spent 10 years developing and commissioning control systems for a major international food processing system manufacturer. But in 2007 he started working for Hydronix as a customer service and software development engineer before becoming a sales manager in 2011. And last year he was promoted to sales director in January. So he knows everything there is to know about moisture, and I'm looking forward to his presentation. Neal, yours.
Thank you, Roger. Hello everyone, thank you for coming to see the presentation. I hope I don't go too long or too in depth. Obviously, any questions, we're around in the hall downstairs, and there's questions at the end. So why do we need to measure moisture? So as we know, moisture comes from the environment, and all of the products that we tend to grow and use are all grown in the environment. So the environmental is always affecting the moisture in the materials that are coming into the processes. It varies continuously as the materials are being used and processed in the factories, and by controlling and adjusting for that and compensating for it, you can then improve the efficiencies of your process steps and improve stability and quality of the final product. So repeatable moisture control can give you higher yields. We can give you higher quality products with higher profitability, and at the same time we can help you to reduce waste in your processes. We can help you reduce the energy consumption, and we can therefore help to reduce the carbon footprint, all by measuring and monitoring and adjusting for that moisture change. So where can we measure moisture in the feed process? So we have various different steps that we need to look at measuring. One of the first obvious ones is in the delivery of the raw materials from the farms and the transfer of those into the storage areas. So the delivery, you can use moisture sensors in the delivery process to spot incoming high moistures to react to that. So either by rejecting materials or by adjusting drying processes that can then pre-dry materials that are going for longer term storage. Again, in the way into storage, you can check for moistures that are going into wet, which can cause hot spots in the in the silos, which can cause obvious problems with that. Then once you've stored and you're using the materials, you've then got the milling processes, the mixers where you want to adjust for the different weights and the proportions of those weights in the dry materials as they're coming in, as well as optimizing any liquid additions for antimicrobials or surfactants, as well as adjusting the final water being dosed into the mixer. And then after that, there's conditioning steps potentially for pellet mills and other extrusion processes. As we've seen, it's very important to have correct moistures at these steps. And then as a final QC, so a final quality check in the processes before you're packaging it, before you're bagging it, or before you're then exporting it in a truck. So how do we measure moisture? So the old or the traditional way of measuring moisture is to take an offline sample. So you can take a sample from the process. You can then use that in a laboratory test or in a handheld device. That can fairly quickly, within an hour or two, give you a sample value for that sample. So you can see what the moisture is for that material. The other option is to measure online. So by measuring online, you can get a fast response to any changes in the moisture. You can monitor it in real time as the material is being processed, and you can react to that. So there's different ways to measure online. We have the capacitance-based moisture sensors, the near-infrared style moisture sensors, which is an optical type, the older analog style microwave measurement techniques, and nuclear techniques, which are generally not too used in the feed industry because of the expense and the critical natures of the nuclear measurement. And then the digital microwave measurement, which we use, which can be used very effectively to get a very stable and accurate representation of the moisture. So why online? Why is that better? So we have, with online, we have full knowledge of the moisture throughout the material flow. So as the material changes in moisture, as it always does, you get a fast reaction to it. So you can see at the bottom here, you have a trace from a system, which is time along the x-axis and moisture up the y-axis. As you can see, it's continually varying. So by taking a sample here, so if you were doing offline samples, if you took a sample here, here, and here, then you can quite easily see that we would get an average value from those three samples, which is a perfectly acceptable way of doing it. But that wouldn't be quite as accurate as the actual the average for the whole batch. So the green line shows that. As you can see, it's 1 or 2% lower than the three samples would give you. So measuring moisture online, what are the options for that? So we have a few different options. There's a lot of different ways to crack eggs and cook coconuts. So near infrared and NIR tend to be quite high costs. They do give you a lot of different measurements, so you can get fat content, protein contents. But they do tend to be affected by the process temperatures. They do tend to be affected by dust and colour changes. They don't tend to be too affected by salts because it's one of the parameters, but they are only a surface measurement. So they tend to be an optical measurement. So if you've got material on a conveyor or something like that, then you only ever get the top level. If it's hot and it's flash evaporating, then that can cause problems to that measurement. Older style online systems based around resistive or capacitance based systems and the older microwave analog tend to be medium ownership costs. They tend to be cheaper to put in but can need a lot of maintenance and recalibration steps. They tend to be affected by temperatures and salt changes. They don't tend to be affected by the dust or the colour though. However, they are a non-linear measurement, which means that when you're actually using the sensor in the real life and you want to calibrate it to an absolute moisture, you need to basically find how that curve is relating to the moisture. Then we have the digital microwave measurement technique. So that has a very low total ownership cost, mainly because the after installation support and service is very minimal. It tends to be very simple to fit, calibrate, and then gives you a very reliable and stable signal. It isn't affected by temperature, salt, dust, or colour, but it must be in contact with the flowing material. So it's worth finding ones that are robust and built to last. What can we get from putting in a sensor in a system? So we looked at a grain dryer. This was a case study we did, and they were looking to prevent the over and under drying of the material. So obviously if the material gets too dry, then they are basically wasting the yield. They want to make it at an optimum moisture level. If it's too wet, that can lead to more mould, spoilage, and a reduced shelf life. So they were looking to dry the material that they were processing from 20% down to 14%. So their original moisture system, they reckoned they could get about 1% accuracy. So they had to target 13% moisture to make sure that they were always under that. So the moisture that you're removing at that point is 7%, and we can calculate that at about 45.9 kilowatt hours per tonne. When they fit the Hydronix system, they could then target to an accuracy of plus or minus 0.5%. So it doesn't sound very much, but it meant that they could target 13.5% moisture, which means they were only reducing by 6.5%, reducing their energy requirement to 42.6 kilowatt hours per tonne. So that's an energy reduction of 3.3 kilowatt hours per tonne, or 7% of your energy costs. In addition to that, they also got higher yield because they were getting 80 kilograms of extra final good quality feed. They were lowering their energy costs, so the actual saving when you calculate it from the at the time current energy costs of, I think it was about 30 pence, 0.3 GBP per kilowatt hour. So that was a £15 British pounds saving, and reduced the emissions. So this is again based on the UK grid, but over 10 kilograms of CO2 equivalent that they reduced by. So if you're looking at getting moisture sensors, there's a couple of things that are useful to look at. Make sure you're using a modern system. So how do you connect it to your plant? Is there a network for the sensors? Can they then link together so you can get data amalgamated and brought to one place? Can you connect different locations that you might have? You can connect sensor networks to external devices for doing things like calibrations and being able to display for the operator. These can then interface with the control system to give you real-time information going in to allow you to control the processes. And then if you've got network connectivity to those, you can then use them with Wi-Fi, with mobile devices, so iPads, iPhones, to then do the calibration to allow it to make it easier for operators and engineers to adjust and troubleshoot. And then on the back end, you can then store data. You can transfer it into MIS, ERP systems to then do a longer term data gathering to watch for any correlations with feed quality issues and high moistures, for example. So just to conclude, by where do we want to measure moisture? There's a number of different places in the processes, from drying through to the bagging. We can react to the changes in the moisture, and there's overall benefits, energy, cost, and the environment. So yeah, many different locations. How to measure it? So you've got offline or online. I would suggest online. I'm a fan of online. I'm an automation engineer by background. And then connectivity. So getting a sensor technology and one that is compatible with the new upcoming systems, like things like Industry 4.0. So I hope that's let you have an insight into some moisture control.
Neal, thank you very much. I think often we overlook moisture and the importance of it, and we just look at trying to save a little bit of product weight. But there's more to it than that, obviously, as we've heard. There's the energy saving and also that critical carbon footprint of ours, which we should all be evaluating or keeping in mind. Every feed mill should know its carbon footprint and should have a program installed where you're reducing your carbon footprint, and this may be one area to look at. Okay, questions. I was going to, at the end, have an opportunity to have questions and a short discussion, but if you have a pressing question as we go along, please don't hesitate, as we heard before, somebody asking a question of our speakers. Okay, our fourth and second to last speaker is Arne Heuer. He's from Amandus Kahl. He's going to speak to us about the Kahl expander in modern feed milling. For more than 10 years, Arne is Area Sales Manager in the Asia Pacific and has been involved, among other things, in the company's expander technology. He is very familiar with all aspects and uses for expanders in the modern feed mill, such as improving feed digestibility, increase the pellet quality and pellet mill capacity, hygiene, which is important, and reduction of anti-nutritional factors, which we all know about. Arne, over to you.
Thank you very much for having me. And also, of course, welcome to you all. Thanks for having us here. And yeah, I hope we can give you a little more insight into the feed milling technology. Thanks again also for the colleagues to start here with. Before now going back into the feed mill technology, I want to take you on a little detour because actually we are part of the Kahl group. So it's a company group consisting of 6 companies. We are all manufacturing and technology providers throughout the world. We have here in Malaysia and Kuala Lumpur our regional office with our regional director, Mr. De Buc. He's also down at our booth talking to the customers. And of course also we are happy to have further discussion with you, so don't be shy, just approach us and we'll happy to discuss. As mentioned, we have different sister companies, and before now going into too much details, I want to dive into a little bit into the newest member of our family. It's company Reinhardt's. They are also producing screw presses for the separation of solids and oils, for example from the vegetable oil, from the oil seeds, but also are recently one of the leading manufacturers for the insect protein solutions. So also here we have one of our experts joining us at the Victam. So if this is an interesting topic you want to learn more about, please also feel free to join us and to have some discussions with our expert at the booth. So then, now coming back to our feed technology, I'm representing here the company Amandus Kahl. We are now in this year having our anniversary, 150 years of operation, and we are happy and proud that we are still going strong. We have our production and headquarters in Germany, and also still producing all our machines over there and shipping them throughout the world through all of Asia, but of course also to South America, North America, and of course also in Europe we are quite active. And to give you a little rundown, we are of course very active in the animal feed, but also active in different other industries. For example, for the biomass pelleting, you may know the wood pellet industry, or also for the ruminant and cattle, the long fiber pelleting is also quite famous and well known by the Kahl flat die pelleting mills. Further, we are also in recycling and pharmaceutical applications. Always when it comes to pelleting and some bulk materials handling, then we have our solutions for that. And then lastly, I also want to introduce a little bit about our newest department that we have in our system, in our company. It is the fluidized bed or powder handling department, where we have special applications for pharmaceutical, feed additives, and other special powder applications. So where we want to have, for example, some encapsulation when it comes to vitamins, when it comes to other feed additives that we might want to mask or to introduce to the animal without them to having the smell or the taste of the active ingredients directly in. Then there are also solutions and options how to upgrade those additives. Also here we have our expert here at the booth, so please also feel free, if this is a topic you want to learn more about, come to our booth and let us discuss this as well. So, and then now coming back to the compound feed and animal feed, I would like to introduce to you again a little bit the history and the developing in the animal feed when it comes to poultry, pig, or also cattle feed. And then of course highlighting especially the expander nowadays. We see this is a very important machine nowadays when it comes to competitive feed milling applications, and it really helps to upgrade the standard process that you now see, I think, worldwide in almost every feed mill. We also saw in the other presentations already how a feed mill in standard is designed, and I think also you may know whenever you visit a feed mill, it is basically the simple same steps, and every company more or less has the same products and machines to produce the animal feed and tries to compete in the market. And I think nowadays when it comes to CO2 emissions, but also to energy prices, to feed prices, it is a quite competitive market, and we try to give our technology to have an edge to optimize your feed mill production, so that we have an edge together and have a long-ship successful partnership. We with our machines, and you with your feed mill. So now coming back again to the process, I mean, as you may know, it all started a little bit easy. We had some components that were ground, that were mixed, to have some recipes so that the animal has a full formulation, so that all the nutrition aspects are fulfilled. Then later on it was also conditioned so that you have increased the actually the digestibility of the feed, and make it easier to digest and have more energy available for the digestion inside the animals. And then later on the pelleting mill was introduced. And I think this is now the typical setup that we see everywhere. Later on I will also show you a little bit more technical details on that. But nowadays, or actually already some time ago, the expander was introduced, and it helps to level up and really increase the efficiency of the plant, and also gives nutritional factors that will also give an advantage in the actual feed that you sell to the customer or that is fed to the animals. So also there I will give you more technical details later on. So let's jump in a little bit. How is the process looking like? What is done in the expanding, and why it is beneficial to the pelleting? How does that work? What is the change for standard conditioning? So basically, you probably all know the conventional conditioning. It's basically a barrel with mixing paddles inside, where you add steam, where you can add some moisture, and you increase the temperature to get the feed conditioned for a better pelletized result. So this is now a little bit dramatic, but of course with good conditioning you have nice pellets, you have a good PDI, and with poor conditioning basically the pelleting mill cannot form a stable pellet, and you will have a lot of dust and a lot of problems to get a good feed out of it. Obviously with a normal conditioner and a good pelleting mill, if everything's set, you kind of make good feed, You have here you can see the residency time is perhaps like 30 to 1 minute in one conditioner, a little bit depending on the capacity and on the sizing of the whole unit. And then you have some moisture, maybe around 13–14%. Again, if you measure it correctly, then you know precisely where you are. You have some temperature increase. Here again, it depends a little bit on what of animal feed you want to produce. And then afterwards, you go to the pelletizer and produce your normal feed. This is really standard basic machines. And if you just want to have a basic feed mill, that might be satisfied for you. But if you have some competitors, this might be not enough, and you might want to consider to upgrade your system. I think nowadays, also we saw in the modular system of ANDRITZ, we see that we have a double conditioning. So you basically increase the retention time, you increase the moisture that can be added, and you allow a higher temperature due to the more steam that can be added in this process. And it will also, of course, help the production because you have a better conditioning result afterwards. If this is not enough, then nowadays also companies and technology provider offer you some retention conditioner. So that gives you some more holding time inside the second conditioner to give you even longer retention time and a little bit better treatment, so that you also then try to further enhance the pelleting quality and the treatment of the animal feed. So when we compare this, well, the moisture obviously is with just standard conditioning a little bit lower. If you have longer conditioning, you can add a little bit more, but you don't want to do too much because otherwise the pelleting mill will slip again. And so you're kind of limited in the options that you can work with, and you have to follow the pelleting mill, the ability to pelletize it, and you cannot just go wild with the moisture because otherwise you will have a problem. And also, we just learned that also when we look at extrusion, if we go with a too high moisture, we also again need a dryer, which will again increase energy cost and is not really beneficial for the overall process. So now let me introduce you to the expander. Basically, what we do is we have one conditioner, which is basically just a simple normal conditioner that you may have already in your line. And then we either just put an expander, or even we have a lot of customers that have existing feed mills and then want to upgrade their process. And then we just take out the second conditioner, replace it by an expander, and can run the feed mill. So what do we do with the expander? So as you can see, the retention time actually is pretty much simple or similar to the single conditioner. We have the single conditioner, maybe 30–60 seconds, and then we go into the expander, and the expander is really just a short treatment. We have a barrel, we shoot through with a feed, and then in the outlet we expand it, and then it's done. So that's maybe 10 seconds in total. And only at the outlet we have the actual expansion effect, which I also show you later a little bit more. Then with the moisture, we can go actually a little bit higher because we have the expansion effect. Similar to the extrusion, we have a pressure buildup, so we also have the boiling point of the water going up. And then with the outlet, we have a pressure drop. So the water again evaporates afterwards, and there we have a steam-off effect, so that actually the moisture that you have at the outlet of the expander is dropping down again to the normal 14–13% that you're used to, and that the pelleting mill also can handle. Besides, due to the barrel and the pedals inside the expander, we also have a mechanical kneading and pressure effect, so that we also have a really good treatment and modifying of the starch and of the components inside the recipe. And then we have a very short treatment with a high temperature. So we go up at the outlet maybe for 1 second to 105 degrees. This may also depend a little bit on the energy input that we have, and that you can actually control with our hydraulic system and the outlet of the expander. And most important, why we also really like to do that and why also customers now upgrade this, they don't want to buy a full complete feed mill. They just install the expander and can run with their existing feed mill 25–30% more capacity. And this is only by replacing one of the conditioners with the expander. And how can we do this? Actually, we take load from the pelleting mill and do the actual work in the expander already. And the pelleting mill will drop with the kVh per ton by half, because it is only a forming. And also what we see is that the press weight of the die can be reduced by 30% so that you don't have so much friction in the pelleting mill anymore, and the work is actually done only by the expander, and then you only produce or form the pellets that will also have a higher PDI due to the higher conditioning before pelletizing. So actually this expander is really a game changer, and how we do this, the most important part of the expander is the hydraulic cone. We have a hydraulic cylinder that moves in a cone out and in and outside of the barrel, and by opening or closing the ring gap around, we can really influence and stabilize the energy input that we put into the feed. So we have a precise control about the intensity of the treatment, and this is very important and crucial for a good process and for a stable feed quality. And then of course, as mentioned already, we have the inlet, so there the preconditioned feed will go in with up to 85 degrees Celsius and a moisture around 16%, and is then going to be treated. And here we have the cone outlet, so this is just at the outlet where we have here the cone, and then here you see the hot zone. So as mentioned, the retention time in the whole expander is probably 8 to 10 seconds, and then only really at the last bit, the temperature, the pressure shoots up for maybe 1 second, and then the flash effect will come in, and suddenly pressure drop, temperature drop, moisture drop due to the evaporation effect, and we have the expanded feed that will then drop to the pelleting mill directly. And by this expansion effect, what also is nice to mention is that we have a little bit like popcorn, the gelatinization effect, so the starch will also be mobilized and gelatinized, so that's easier accessible by the animals, and we have a higher nutritional value and a better feed conversion rate, because the animal can take in more energy by the same feed amount. So here again a little bit more clear picture. Here you see a grain and the cell structure as a raw material, and then after the expansion you see that the cells and the inner starch molecules are really disrupted, open up, and ready for easy digestion. So here, just to give you a roughly rundown, what are the benefits? We have the nutritional factors, so it's easier for the digestion of the animals. We have the production inside the feed mill that is increased. We have, due to the treatment and the high pressure, we kill all salmonella, because the bacteria cannot withstand this pressure drop. They actually will explode more or less, and then deactivate it afterwards. And also with this better conditioning, you will also have a better pellet quality that you actually really can see. We have customers, one line with expander and one line still without. And when you compare just when you open the pelleting mill and just take a sample, you can really see that with the expanded feed, you don't have the fine dust. And with the normal conditioned feed, you usually have a higher amount of dust in your hands. Here also now to give you some recent success stories from the region. This is a customer in Vietnam. They have already 12 expanders running, and just beginning of this year they have placed the order for another 6, and most likely there are more to follow. In Japan we have already, I think, roughly 70 machines running. Brazil, big market and big feed lines with up to 60 tons. They are also all using expander, because in these high capacities you basically need the expander to have the good feed quality and the big high capacities that is necessary in the market. And then here another example from Indonesia. They have tested and started with 2 expanders, and now have just beginning of this week placed another order, so that we have now in total 12 expanders in the order book, and are happy to further develop this, and also see that the market is recognizing it and appreciating the higher feed quality that can result in it. And also maybe one thing which I not mentioned yet, if you're looking for duck feed, this is especially crucial because of the high fat content in the duck feed. It is usually quite hard to pelletize, and you have to make sure that with the high fat content, the pellet mill does not slip. If you had an expander, we see that with our customers, they can double the capacity. So usually they maybe run 7.5 tons. Afterwards, they run 14 tons, 15 tons with the expander. So also here, if you have further questions, if you would like to learn more, please come to our booth, and we are happy to share with you more advantages and also dive deeper. And of course, also always happy to join you in your feed mill, visit you. Our regional director, as mentioned, is located in Malaysia. And we have the local agent network, also happy to support and to give you the after-sales service.
Thank you very much. Thank you very much. There's a lot to consider when you start delving into the benefits of something like an expander. And it was a novel way to look at that. You know, we all know of expanders, but to look at that in detail, I think was very informative. Okay, we've come to our last presenter for today, and that's Sven Konings. He's from TSC Silos, and he's going to address us on storage as a strategic component of feed mill design. As you know, we have sort of travelled all the way through the milling process in no particular order, but we've been touching on highlights, and I think storage is a really important highlight. We know that the industry, or the grain industry, is losing 25% of all stored grains annually, globally. It's unacceptable that we are allowing, as an industry in the food sector, for that to happen. In Africa, these losses are up to 50% of all harvested grains never made it into the food manufacturing process. So it's a great topic, and with 12 years of experience at TSC, Sven operates at the interface of engineering and business development. He supports clients and partners worldwide by bridging process requirements and structural design to deliver tailor-made integrated storage solutions focused on accountability, efficiency, and long-term performance. Sven, the floor is yours.
Cool. Thank you. Well, good afternoon, everybody. Thanks for joining us today here. Well, after such an introduction, I can't even compete with that, so I'll skip that part. A short introduction on TSC Silos. Almost 30 years now that we are, as TSC Silos, focusing on square silos and structural related steel structures on these square silos. Meaning we've built quite a lot of feed mills, for example, over the past almost 30 years. What are we talking about today? Storage, or more in particular, process storage. Well, Roger, you may have said it a little bit. It's often, we feel like it's a little bit overlooked, because if you do it well, if you design your mill well and think structurally early on in your flow diagram, so to say, you add that thinking, we feel you get a better mill, a better performing mill that lasts longer. So why talk about storage? Well, for that matter, we feel like storage is often seen only as volume of a buffer. It's part of a necessity, maybe even, or it's boiling down to tons we need to produce and how many silos we need to store that tons. But storage defines a lot, especially in mill buildings. Process storage defines a lot. It has an impact on the building footprint, the building loads, meaning the foundations of the underneath the structures. It impacts performance reliability. I'll get back to that later. Also expandability, a little different than the expansions we've talked before, but if you design it with the future in mind, you can easily expand your feed mill in the future. And an increasing more important topic is compliance. Just to be on top of mind, to have it on top of mind, a nice feat we recently found out ourselves is that in many modern mills, the square silos represent 60 to 80% of what is visible in the structure. I think the video gives an idea where that 60 to 80% comes from. So storage has impact, of course, on your production, your intake and your production stability. I mean, how much you stores that feeds into your process is how much you can produce. So these silos integrated into a structure have an impact on flow behavior is an important part for those silos. So it's also part of the structural design of such a building. In the end, good storage lowers the risk on downtime and decreases the actual downtime. And again, storage has impact on the structural loads, storage has impact on your foundation, which is a not neglectable part of the costs in the end. So we as TSC, of course, advocate for square silos in mills. Square silos are the most efficient way to build silos. It is often integrated into your structure, so you don't see them afterwards anymore. It's one compact building. You can integrate it with your steel structure, meaning you benefit in terms of connectivity on loads, structural integrity. Of course, the optimized footprint, because you need less space to achieve more productivity, and you create a hygienic and enclosed environment. So there are quite a few benefits to integrating square silos into your mill building. But of course, silos in the end, what do you want is that a silo, it must go empty. So flow behavior is not just theory. You don't want to hammer on a hopper because the product is stuck. Product characteristics matter. Even in this simple video, it's the same hopper, but the one with an insert, and you see the flow is simply different. So how you design a hopper, how you design a silo, how the process equipment underneath the hopper, what that looks like has an impact on how the product flows. So equipment choice determines outlet size. On the other hand, a good designed hopper may also influence the choice of equipment. But in the end, it influenced the discharge reliability. And then we have a good, well-designed silo. Now we have to integrate it into the structure. Why would you do that? Well, again, storage loads define building structures. This is not, if you add 300, we are talking silos that are 200 tons of storage, but if you have one of them, okay, that has an impact, but you can see here, this is one with, I believe, 24 bins of such. That has an even greater impact, of course. But by early integration, early thinking, early including the structural thinking into your process, into your project, you can optimize, you can diversify the loads, you can reduce, in the end, the impact on the foundation. And when done properly, it improves the long-term stability of the construction and increases the user-friendliness. It's an often overlooked part of mill design, I think. I've visited quite some mills over the years where you have to dive to get underneath to the next section of the mill. When thinking ahead, I would say those are avoidable problems. But with structural integration comes structural compliance, and this is an even greater topic, a topic that is increasing in importance. We come to experience worldwide. Scrutiny from legislators is increasing on whatever structure you are building. But we have to work with different norms, different way of thinking, different products. So we have to consider local external loads on a silo structure, meaning seismic, hurricane loads, in Europe, snow loads. So there is a lot of difference, and no two mills are the same, but what they do have in common is, in the end, they need to have a traceability of design documentation. So the documentation, the design must be planned, must be verifiable and reproducible, very important. Because again of that increased scrutiny we face from legislators, and that's no small feat. It's hours and hours of questions back and forth with legislators that are testing, checking the calculations we made on such a structure, for example, and it's not getting less. Touched on it before already on containerized or modular plants. This all might seem, what I've said so far, really relevant for conventional mills, but it's also very relevant for containerized mills, because you are limiting yourself in that matter in a containerized mill in terms of space. even more so because indeed it's often installed inside of a hull. So you're also limiting yourself in height. And that really means you need to plan ahead because basically every modular mill we've contributed to must be easily expandable in the future. So it's also a way of thinking, because if you're expanding in the future, how do you provide something that's modular, making it still easy to expand, usable, user-friendly for in the future? That's also a very relevant topic, of course, for a structural integration of silos, and wherever the it's how do you say, the process and the silo structures, for example, not necessarily are structurally integrated, but they intertwine. They are very relevant to each other, and good design also for the silos in this case makes for an easy to use, easy to expand modular mill. So my case here is that storage is not a passive component of a feed mill. It is an engineered system that defines reliability, safety and long-term performance, and if done well, it impacts positively on the long-term performance as well as the durability and usability of a feed mill. And with that I come to my conclusion. Thank you. I have to do the honoring words myself, I guess. Yeah. There's a man out here. Yeah. Sorry to caught you by surprise, Roger.
Thank you very much, Sven. Sorry, I just had to check something outside. I think overall we've had 5 excellent presentations, and I think to end on this particular one is worth remembering already is that we have to protect our raw materials coming in. And in silo storage, as we just heard, there's different types of silo constructions out there, but we have to pay attention to silos in order to maintain the quality of our raw materials. Okay, I want to thank our sponsors, and most of our sponsors were speaking today, which is really good, that they not only contribute presentation and take us through some of their technologies, but they also support us in hosting these valuable interchanges, and that's Famsun, ANDRITZ, Hydronix, Kahl and TSC. There's an opportunity I have for 5 minutes. I know we're running late. Apologies for starting so late. There's a bit of a mix-up on when we got the hall. So we're about half an hour running, almost half an hour running over. So I'll be happy to close now. But if there's a question, we have our speakers here. We would like to offer the opportunity. If you have something to discuss or something to say, please take the microphone. I'll give it to you. Introduce yourself and have a say. We'd like to hear from you. While you're thinking about that, and I'll come back to you, I'd just like to say from my point of view, I've made a few notes today myself, and we've gone right from the definition of extrusion right the way to this very important subject of storage. We've seen videos, a couple of videos that have shown us the inside of production processes, which I think getting a look at some of these things is important. We've looked at extrusion versus steam pelleting, and I know in this region steam pelleting is still pretty much in aquaculture a strong contender in that area. We looked at a containerized feed mill and the construction of that in very close detail, which we wouldn't get anywhere else. And I think that that was a really impressive presentation. And Neal has talked us through the importance of reviewing or redefining our carbon footprint when it comes to the usage of moisture. What is the moisture that we're allowing in our materials and why, and can't we make some savings all around, and especially on carbon footprint. Kahl, with its 150 years celebration this year, has made a huge contribution to milling in this part of the world, Its expanded technology is second to none, and for the reasons we heard today. So I think that 25 to 30% increase in throughput and all those other nutritional values and hygiene that he mentioned are really worth considering a lot. And of course, we've also just now heard from KSC from Sven on silos. But we've had 5 excellent presentations, and I think there's a lot of takeaway messages here. And the topic that we've addressed today is feed milling maximised. And I think you can see throughout those presentations, we're being encouraged to maximise what we get from the production process, not just in terms of profitability, but in what the farmer gets in the utilisation of the materials that we produce for him in the form of feeds. So very pleased to have you here. Thank you for going the distance. Let's give a round of applause to our speakers. They've done an excellent job.